Yesterday I explained different plotting techniques to plot 2D 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 diagrams. Now next overlay plotting. How to plot more than one curve with different colors. If you give a hold on, same color is coming in. How to get more? How to plot more than one curve using MATLAB. For example, I want to plot y is equal to sin x, y is equal to 2 sin x, y is equal to 3 sin x in closed interval of 0, 2. I want to plot 3 curves in a single window, single figure window. How to do this? This is called overlying plot. This we call it as overlying plot. First, we have to define x value. X is equal to linspace 0, 2 pi. Zero comma 2 pi. So that means we'll get 100 points in a closed interval 0, 2 pi. Now I am defining function y is equal to sin of x. So y1 is equal to 2 star sin x. Y2 is equal to 3 star sin x. Now what we have to plot x comma y, x comma y1, x comma y2. We get 3 curves. Okay, we get 3 curves. Now we know the shape of y is equal to sin x, y is equal to sin x, y is equal to 3 sin x. So we can easily identify the maximum value of sin x is 1. So this is sin x curve. This is 2 sin x. This is 3 sin x. Why? Because the maximum value of 3 sin x is minus. Minimum value of 3 sin x is minus 3. Maximum value of 3 sin x is plus 3. So we can easily identify. This is the first curve, sin x, 2 sin x, 3 sin x. But suppose if you don't know the nature of the curve, it is very difficult to identify the shape of the curve. It is difficult to identify the curve. For that, there is a command, legend command. If this command, this is the first data. So first data is x is equal to y is equal to sin x curve. Sin x curve. Just we have to double click on this one, sin x curve. Second curve, x is equal to y1, 2 sin x. This is third curve, 3 sin x. Sin x curve. In this case, the legend will help you a lot. Okay. So now I want to remove this excess part, so that once again I am telling. Suppose if you want to insert x axis, y axis, and all this, we can do. So I want to remove this excess part. Okay, 2 star PL. x-axis, x limits. Okay. This is about this is a method to plot more than one curve in two dimensions x-axis. Whatever you want, you can do it. Okay. And this is the way plotting more than one curve in LaTeX. In MATLAB. I didn't understand. Can we write x value in pi from here? Yes, we can write. That we can do. That we can do. So all the things I will tell. Yesterday also one madam asked how to change these values. That I will tell you later first. All the things we can do. Okay. Okay. Next, suppose I want to plot. mm, So for example, y is equal to x square. Plot y is equal to x square. Y is equal to x square. And x plus 2. We take x plus 2. X plus 2y minus 3 is equal to 3. In we take some interval minus 2 2 plus 2 or minus 3 2 plus 3. Every time we are taking positive interval. This I want to do. So first you have to take some x values in the given interval. X is equal to mean space minus 3 comma 3. Some 50 points. Okay. 50 points I'm taking. First, y is equal to x square. Y is equal to x dot cap. Whatever the second curve. Second curve y is equal to 2y is equal to 3 minus x. 2y is equal to 3 minus x. Y is equal to 1 by 2 into. This is the y value. So y1 is equal to 0.5 star 3 minus x. That's enough. Plot x comma y comma x comma y. Yeah. And also, okay. This is the intersecting point. Am I correct? Maybe one more. Yes. Okay. Okay. Uh, now, okay. What do you want to do? This enough. Okay. So we want to better this point. This ordered pair also we can represent. Correct? Point is not coming. Both values are same, no? But the point is not included in this interval. That's why it is not coming. Hmm? I want to know the intersecting. Now definitely intersecting point will be, you can get intersecting point. That is 1, 1. But because 0.1 I have given, intersecting point is 1. X value, Y value should be the same. Intersecting point is 1, 1. That point also you can insert here. Delete all derivatives. There is insert text box. Otherwise, text 1, comma 1. We can remove this text box also by seeing edit. This box also we can remove. Okay. So edge color, no color. Ordered pair. This is ordered pair. This one. Okay. Like that we can do. Okay, now I'm going to take one more curve. You see this one. Not only this one, we already have. We can give different for different curve. We can give different markers also. Okay, markers also we can. These are options. Okay. All these things we can. Next, next I'm going to plot one curve. You see this. CLC x is equal to length space 0, 1. That means I have taken 100 points in the closed interval of 0, 1. Y is equal to x. That is a straight line. Y is equal to x dot have to x square. Y is equal to root x. X dot 1 by 2. That is next y1. This is y1. This is y2. Next, y3. Y3 is equal to x cube, y4, x dot cap 1 by 3, y4, y5 equal to x dot cap 4 by 6, x dot cap 1 by 4. That means I have taken y is equal to x, y is equal to x square, y is equal to root x, y is equal to x cube, y is equal to x cube root of x, y is equal to x to the power of 4, y is equal to 4th root of x. Okay, 4th root of x. Okay, we take one more curve. We will stop otherwise. Plot x comma y, x comma y1, x comma y2, x comma y3, x comma y4, x comma y5, x comma y6. This is y is equal to x, y is equal to x square, x cube, x cube, x to the power of 4, cube root of x, 4th root of x, 6th root of x, 5th root of x, 4th root of x, sorry. X cube, x square, x cube, x power 4, root x, cube root of x, 4th root of x. So these curves are intersected 0, 0 and 1, 1. Am I correct or not? So that's why we are getting like this. If you add one more, or two more curves like this, we will get like this. X to the power of 5, 5th root of x. Like this. Okay. With this, I'm closing this topic and I will move to another topic in MATLAB. Any doubts on this? Any doubts? Okay, no doubts. Now I'm going to explain. So now we plotted a single curve in figure window, more than one curve in a single window. Now I want to plot more than one curve. Suppose this is the figure window. I want to plot one curve here, one figure window here, one figure here, separately. Here another figure. Here another figure. Here another figure. This is total figure window. In that, I have to get one figure here, one figure here, one figure here, one figure here. This is called subplot technique. Subplotting of curves. Subplot. So for this, how many rows are there? 2 rows, 2 columns. Okay. So this is one element. Okay. This is one element. This is one element. This is one element. This is one. 4 by 4 element. Four elements. Four figures we have to insert in one figure. So for that, what we call it, this window we call it as 2 to 1 method. Two rows, two columns, first window. This we call it as a 2 2 2. Two rows, two columns, second question. 2 2. This is called 2 2 3. 2 2 3. 2 2 3 window. This is called 2 2 4. Like this, we'll mention 2 to 4. Suppose the plot I want to plot like this. I want to plot like this. Here one figure. 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 How to name this as? What is the name of this element? How to tell? Hmm? What is the name for this window? What is the name of 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 this window? Then only we can plot. Then we have to mention, we have to tell to the MATLAB. I'm going to plot two rows, three columns. First one, okay. Two rows, three columns. First one. Next, 2 3. Yes, yes. 2 3 1. Next one. Yes, yes. Next one. Next one. 2 3 1 3. This is 2 3. Am I correct? This is 2 3 1. 2 3 1. What about this one? This is 2 3 2. This is similarly. This is 2 3 3. 2 3 4. 2 3 5. 2 3 6. Like that, we have to insert. We have to tell to the 2 3 5. This is 2 3 6. 2 3 6. Now we have an idea. Somewhat we can do. Now how to give this commands to MATLAB? Hmm? How to give this command? So to follow some see listen. First, I want to plot. So I'm taking 0 to some 0 to 2, 0 to 3, for example. I is equal to x is equal to 0 column 0.1 column 3. Okay, x. So y is equal to x is extraordinary. Y is equal to extraordinary. Subplot. Otherwise, you first you define, that is better. No doubt. 4 plots, 4 y's you define. Y1. Y1 is equal to sin of x. Y2 is equal to exp of x. 1, 2, 3, 4. Y3 is equal to Y3 is equal to some causes. Some another curve. Cos x. Cos x. Okay. Now, what we are doing? Subplot. Subplot. What is this one? 2, 2, comma, 2, comma, 1, comma, plot x, comma. This is a figure window. Here it came. This diagram y is equal to x square. Next, subplot 2, 2, 2, plot x, comma, y1. That is y is equal to sin x. Subplot 2, 2, 3, plot x, comma, y2. Okay. Subplot 2, 2, 4, plot x, comma, y2. Okay. These are 4 curves. Suppose if you want to do anything, select this one, X label, Y label. If you want to change anything, you can. Okay. Yes. Okay. Tools. Insert. X axis. It will come X axis. Why? Because I highlighted this one. I selected this one. Okay. X axis. Insert. Y axis. Y axis. Okay. This is insert title. This is y is equal to x square. How to bring x square? As usual, x cap. Multiplied by y is equal to x square. Okay. So if you want to edit something, you want to do this one, again you select. If you want to do this one, if you want to change the color, change it. Okay. All these things we can. X axis, Y axis. Okay. Like that we can do all the things. Okay. This method, this technique is very useful when you want to compare one data with another data. One data with another data means one curve with another curve. Good. Any doubts on this? Any doubts on this? Any doubts on this subplotting technique? If you have no doubts, I will ask. Okay, madam told her no doubts. I will ask one doubt. Malleshwari, something. Malleshwari Katampetti. This is my figure window. This is my figure window. I want to plot one here. I want to plot one curve and one curve. How to do this one? Malleshwari Katampetti. Tell me. Maleshwari automatic. Where are you, Maleshwari madam? Hyderabad, you told na? Hyderabad.
No, sir. Nandel, sir.
Huh? Where are you from?
Nandel, sir.
Nanda.
Kannur district.
Nanda, yes, yes. How to do this? Any
1 minute, sir.
okay, don't refer any book. In the, you have any idea? Anybody? Others? Today Haripriya absent. Where is Haripriya? 2 2 2 1 1 2 1 2. Oh, wait, wait, wait. What is this one? Different Mahati. Mahesh Malish Muhammad. 1 2 1 2 2 1. Okay. 2 2 2. Next. Any idea? From participants. 7. 2 2 what 2 2? Okay, I will tell you. First, let us assume these are the 2 rows and 2 columns. I want to plot one here. How to plot this? Already x comma y comma all values are there. Subplot 2 comma 2 comma 2. Am I correct? Plot x comma y. Here one plot came. No problem. Am I correct? I want to get a plot like this. Here one plot, here one plot. What about this one? 2 2 2 2 2 4. 1 3. Why it came 1 3? 1 row 3 columns. Subplot 2 comma 2 comma 4. Plot x comma y 1. Okay. Now here one plot came, here one plot came. Now here in bit, these two I have to merge. I have to get one single plot here. 1 3. Am I correct? So subplot 2 comma 2 comma 1 3 merging. 1 3 merging. Is plot. I'm taking is plot. Not only is plot, general plot also we can take. I'm taking my option is I want to we can do anything. Not only plot stem we can use area. Anything just I'm here taking is plot. Sin square x by x is sin x by x. Sin x by x. Okay. So if you have no doubts, otherwise I will general I'll take subplot. Subplot. Not is plot and then plot. plot x comma y. Okay, this is about energy. Now you can tell, this is collage, exactly equal to the collage. We are doing the clause. Here one plot, here three plots. How to do this? Tell me the commands. What do you want, Mamata Kumari? Mamata Kumari. What do you want? Once again explain, sir. What? Which one? This plotting? No. There are two curves. Actually, I have a plot here, one plot here. I want one plot here, one plot here. I want to merge these two. That is the thing. I want to get a single plot here. So there are four windows are there. I am merging these two windows. This is 222, this is 224. So 221 and 223 I have to merge. 221 and 223 I have to merge. This is I am doing like this. 221 and 223 I am merging. 2213 I am merging. So I am plotting. This one you are asking anything others. Anything you want other than this one. Okay. Okay. Now my question is this one. How to plot this one? I want to plot one curve here. Here three curves. What are the names for these windows? Tell me what are the names for these? Farooq Hussain in Mother. Okay. Next. Ashwari. Okay. Okay. Next. Next. What next? 2, 3, 1, 2, 3. Next. 2, 2, 4. 2, 2, 5. 2, 2, 6. Am I correct? So I will do it. I will do it. Okay. Okay. See, I see. Subplot. Two rows, three columns. 1, 2, 1, 2, 3. I want to make 1, 2. Okay. Plot x comma sin x. You can view like this also. I am telling all other options. Okay. Sin x. Like this. Subplot 2 comma 3 comma 2 comma 3, comma 4, 2, comma 3, comma 4. Oh, sorry. 2, 3, comma 4. Somebody told me 2, 3, 4. Dot x, comma y1. Okay, x, comma y. 2 to 5. X, comma y2. 2 to 6. 6. X, comma y2. Finally, see it. Finally, see the output. Okay. This is about 2D plotting. 2D plotting. So tomorrow I will start parametric, and today I will explain what is this. Suppose parametric curves. Something I will explain. Little bit I will explain. Tomorrow I will start. Parametric curves are. Am I correct? Parametric curves. What is the parametric equations of a parabola? The parametric equations of a parabola. What are the parametric equations of a parabola? Parametric equations of a parabola. For the parametric x is equal to at square, y is equal to 2. Well, just I am doing parabola we can draw, but I want to plot the parabola with respect to using parametric equations. So this is the parametric equation. How to plot this type of curves? Suppose the asteroid equation is there. X is equal to sine to the power of 3 by 2. Y is equal to sine to the cos to the power of y is equal to x is equal to cos to the power of 3 by 2. Y is equal to sine to the power of 3. Parametric equations. Like that curves. How to do that? First we define Ty. Suppose T is T is equal to 0.0.11. X is equal to at square. A is equal to 1 ampere. T dot y is equal to 2 star T. Plot x comma. Get parameter equation. Okay. Parameter. Suppose if you take this value minus 3 to plus 3, you get a complete share. Okay, like this. This is about parametric equations. Okay, now tomorrow I will explain some parametric equations, cycloids, hypocycloids, like cycloids, hypocycloids. For example, epicycloids, epicycloids. So cycloids, an epicycloid or a hypercycloid is a plane curve produced by tracing the path of a chosen point on the circumference of a circle called an epicircle, which rolls without slipping around a fixed circle. An epicycloid or hypercycloid is a plane curve produced by tracing the path of a chosen point on the circumference of a circle called an epicircle, which rolls without slipping around the fixed circle. For example, if you take this one, this is called epicircle. This is called epicircle. So the locus of the point on the circumference of the circle, which rolls on a circle. This curve, the red color curve, is called epicycloid. An epicycloid or hypercycloid is a plane curve produced by tracing the path of a chosen point on the circumference of a circle called an epicircle, which rolls without slipping around a fixed circle. Okay. Here, what is the radius of the smaller circle? The radius of the smaller circle is 1 unit. The radius of the bigger circle radius is 3 units. Am I correct? This is 3 units. This is 1 unit. That's why we are getting 3 cusped. 3 cusped. This is called cusp. 3 cusped epicycloid. If it is, this radius is 4 units. This radius is 1 unit. We'll get 4 cusped epicycloid. What is the now I want to draw this. I want to draw this curve epicycloids for different values of different ratio values. The smaller circle has a radius r and the larger circle has a radius kr. That is ratio k. Then the parametric equations of the curve, which can be given by the parametric equation of the curve means the parametric equations of the epicycloid are given by like this or like this. This is the simplest form of epicycloid. This is the simplest form of epicycloid. So we have taken Kr is equal to Kr. So Kr is common, K plus 1. X of P is equal to R into K plus 1 into cos T minus R into cos of K plus 1 into T. Okay. Y of T is equal to R into K plus 1 into sin of T minus R into sin of K plus 1. If K is a positive integer, the ratio is a positive integer. If it is 1, if it is small radius is 1, capital radius is 3. Small radius is 2, capital radius is 8. Ratio is integer. Is a positive integer. Then the curve is always closed and has k cusps. If k is a rational number, say k is equal to p by 2, which is the simplest form, then the curve has p cusps. If k is an irrational number, then curve never closes. So for k is equal to 1.2, that is 20 by 21 by 10. 21 by 10. 21 by 10. The curve has p cusp 21 by 10. K is equal to 21 by 10. 21 cusp epicycloid 1, 2, 3, 4, 5, 6, 7. 1 second, important call. Akhil. Akhil. ఎయిర్పోర్ట్ వచ్చావా ఓకే ఓకే అదేం లేదు అదే అది వీడియోకి తెలుగు సాంగ్స్ ఏమన్నా ఏమన్నా ఓకే ఓకే అంటే మాది కూడా చూస్తాను ఏదో నైట్ నైట్ ఇంటికి వెళ్ళిన తర్వాత ఫోన్ చేయి ఇంటికి వెళ్ళిన ఓకే 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 ఎన్ని గంటలకి బయట ఓకే
Sir, your mic is mute.
Oh, sorry, sir. Sorry, sir. It's muted. So 21 first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 21. 21 plus for episode. This 3.8, 38 by 10, simplest form, 19 by 2, 19 by 5, 19 plus for episode. So I have one video on the epicyclid and hypercyclids, and that is there in YouTube. If you want to get a clear idea about tomorrow class, you watch this video. Epicyclid parts using MATLAB. Okay, enter. This is my video. So there are some disadvantages. My student did wrong actually. We have to use earphones. Then only it will be video will be clear. Okay. Sorry, audio. Audio will be. You take earphones and view this video, and tomorrow come to the class. Okay. Then you can easily understand. Okay. Okay. So I have an urgent work. So I have to leave now. Okay. So any doubts on this one? Any doubts on this class? You can tell. Otherwise, I will leave. Tomorrow, I will continue the class. Tomorrow, Sunday, I will take a question. Some Sunday also, I will take the class. Same time. Okay. Okay, sir. Sir, Rajesh, sir, I am leaving today. No doubts.